सभी का नमस्कार। आज का जो हमारा टॉपिक है रिलेशनशिप बिटवीन जीरोस एंड कोफिशिएंट्स ऑफ अ क्वाड्रेटिक पॉलिनोमियल. So today we will establish a relationship between the zeros of a quadratic polynomial and the coefficients of a quadratic polynomial. So first let px is equal to ax square plus bx plus c. It is a quadratic polynomial since its degree is 2. This is the general form of quadratic polynomial where a should not be equal to 0 and a, b, c, they belongs to set of R, that is set of real numbers. So they may be rational or irrational, so they are actually called as the real coefficients of the quadratic polynomial. And let alpha and beta be the two zeros of px. If alpha and beta are two zeros of px, then we already know that p alpha will also be equal to 0 and p beta will also be equal to 0. And in class 9th we have studied that if p alpha equals to 0 and p beta equals to 0, then by factor theorem x minus alpha and x minus beta are the two linear factors of px. So if x minus alpha and x minus beta are two linear factors of px, then their product will also be the factors of that px, that is ax square plus bx plus c. Here we have taken k. What is k? K here is a constant. Why we take constant? So let's take an easy example. Let us suppose that the number is 36. Its two factors are 4 and 3. So if 4 and 3 are its two factors, then their product, that is 4, 3 are 12. 12 will also be factor of 36. Now to equate the two sides, since 4, 3 are 12, 12 is not equal to 36, so we take a constant k, and in that case the k takes the value of 3, k equals to 3. So 4, 3 are 12, 12, 3 are 36. Now take another example. If we write 36 as say the factors of 36 be 12 and 3, so then their product will also be factor, that is 12, 3 are 36, and in that case to equate both the side we take again k as a constant. So in that case k equals to 1. Since 12, 3 are 36, 36 1 are 36, so we always take k. So here also we have taken the k, and that k may take any real values. So by distributive property we will multiply x minus alpha and x minus beta. So first x is multiplied with the whole expression x minus beta, and then minus alpha will be multiplied with the expression x minus beta. So x within the bracket x minus beta minus alpha within the bracket x minus beta. So x is multiplied to x, so we get x square, then x multiplied to minus beta is minus beta x minus alpha x, then minus into minus beta is minus minus plus alpha beta. From these two terms we will take minus common and x common, so we will get this term x square minus alpha plus beta x plus alpha beta, that is within the bracket alpha plus beta. Now this whole k, now this k will be multiplied with the whole expression. When k is multiplied to x square we get kx square. When k is multiplied to minus alpha plus beta we get k alpha plus beta x. When k is multiplied to alpha beta we get k alpha beta by distributive property. Since both the left hand and right hand side are equal, so that will only be possible if their coefficients, if their corresponding coefficients will also be equal. So here the coefficient of x square is k, and here the coefficient of x square is a. Here the coefficient of x is minus k alpha plus beta, here the coefficient of x is p. Here the constant term, that is k alpha beta, and here the constant term is c. So they will also be equal. So on comparing the coefficients of x square, x, and constant term on both sides, we have this, that is a equals to k, b equals to minus k alpha plus beta, and c is equal to k alpha beta. So a is equal to k, so the constant is k. Here from this expression we will get alpha plus beta is equal to b upon minus k. And what is k? K is actually a, so we can write it as b upon minus a, and we can shift minus to the upper side, that is minus b upon a. So in that way the alpha plus beta, which is sum of the zeros, is equal to minus b upon a. And what is b? B is nothing but it is actually the coefficient of x. So minus coefficient of x upon a. What is a? A is actually coefficient of x square. So sum of the zeros is actually equal to minus coefficient of x upon coefficient of x square. So this is the relationship which we have established between the sum of the zeros and with the coefficients of the quadratic polynomial. So if we know the coefficient of x and coefficient of x square, then without factorizing them in linear factors, बिना फैक्टराइज किए हम किसी भी क्वाड्रेटिक पॉलिनोमियल के सम ऑफ द जीरोस को हम फाइंड आउट कर सकते हैं. अल्फा बीटा इंडिविजुअली तो हम फाइंड आउट नहीं कर सकते, बट वी कैन फाइंड आउट देयर सम. Similarly, product of the zeros we will get from this expression. So alpha beta is equal to c upon k. So product of the zeros, since alpha and beta are the two zeros, so alpha beta means alpha multiplied by beta. So product of the zeros is c upon a, since k is actually a. So c upon a. So what is c? C is actually the constant term in that quadratic polynomial. And what is a? A is the coefficient of x square. So if we know the constant term and the coefficient of x square in quadratic polynomial, then we can find out the product of the zeros. अगर हमें constant term और coefficient of x square मालूम है, तो हम प्रोडक्ट ऑफ द जीरोस तो फाइंड आउट कर सकते हैं. इंडिविजुअली अल्फा और बीटा की वैल्यू हमें शायद ना पता हो, लेकिन हम उनके प्रोडक्ट ऑफ द जीरोस को कांस्टेंट टर्म और कोएफिशिएंट ऑफ एक्स स्क्वायर की हेल्प से उनका प्रोडक्ट ऑफ जीरोस फाइंड आउट कर सकते हैं. सो जो चीज़ हमने सीखी है वो ये है कि अगर हमें कोई क्वाड्रेटिक पॉलिनोमियल दिया है और उसके कोफिशिएंट्स अगर हमें मालूम है, कोफिशिएंट ऑफ एक्स स्क्वायर, कोफिशिएंट ऑफ एक्स और कांस्टेंट टर्म, तो हम अल्फ़ा प्लस बीटा और अल्फ़ा बीटा फाइंड आउट कर सकते हैं. अल्फ़ा और बीटा हम इंडिविजुअली तो फाइंड आउट नहीं कर सकते, लेकिन हम उनके सम फाइंड आउट कर सकते हैं और उनका प्रोडक्ट बता सकते हैं. और वाइस वर्सा भी आप सपोज कर सकते हैं. अगर आपको किसी क्वाड्रेटिक पॉलिनोमियल के अल्फ़ा सम ऑफ द जीरोस पता है, सम ऑफ द जीरोस की वैल्यू पता है और प्रोडक्ट ऑफ द जीरो की वैल्यू पता है, तो आप क्वाड्रेटिक पॉलिनोमियल भी फ्रेम कर सकते हैं. फॉर एग्जांपल, if we know that alpha plus beta is equal to 7 and product of the zeros is say 4, so we can frame a quadratic polynomial. We know this expression, that is k x square minus alpha plus beta x alpha beta. By using this expression k x square alpha plus beta, instead of alpha plus beta we will write 7x, and product of the zeros, that is alpha beta, instead of alpha beta we will write 4. So this is the quadratic polynomial which is related to the sum of the zeros 7 and product of the zeros 4. And we can change the values of k, as k may be any real number. So related to this sum of the zeros and product of the zeros, we have infinite number of quadratic polynomials, since k may take any real value. So that is all from my side today. Thank you.